Hey folks, in this video we're going to write a simple C program to load a BMP and displace information on it. To do that, we'll follow along with the binary file format specification. So let's go ahead and get started. So I have basically a simple C program up, and I've already added my image to the folder where the program is on my computer. I also have the image specification up. The specific image we'll try loading is the 2x2 that we've used in other videos. So let's see. I'm going to have to basically introduce 4 new C functions. All these will all be available to us from the stdio.h file. The first thing I need to do, right, if I'm thinking about looking at a file, is open it up. So we'll start with that. This line may be a little familiar with things you've already done before. So we'll call this file input, and we'll use fopen, right? That's our function here. In this case, our file name is going to be Wikipedia 2x2.bmp. That's our file. And the next argument here is going to be the file format. So this is how we tell C that we're going to be working with a specific type of file. In this case, it'll be a binary file. So I'm going to write RB. RB stands for read binary. We have a binary file and we want to read it. So basically that just kind of makes sense. All right, so here, right, is enough code to kind of open our file. We're not quite done yet, obviously. Let's see, what else do we need to do? Let me go ahead and put in a close command. That way we can be sure that this program kind of cleans up after itself. Now these, of course, right, are the easy bits, but we want to make sure that they're there. Okay, so now I have my file open. How do I get data from it? Well, what I'm actually going to do is take the kind of approach of defining the file format in C before I try doing anything with it. So what do I mean by that? Well, let's take a look first at the bitmap file header. Let's see if we can write a struct to represent that in C. Because then at least we'll have basically a way to name the components of it. So we'll call it, maybe BMP header. Okay, so BMP header. What this is a bit of code that will represent that green block on my screen over here, this part of the file specification. So let's see, what can we put in here? Well, first thing is going to be the signature. And the signature from the diagram looks like it has 2 bytes. Well, what type of variable has 2 bytes in C? It's kind of weird. There's no variable that's 2 bytes long. What can I do? I can make an array of 2 characters, and that'll actually store those first 2 bytes. Or for the BMP format, it'll store that B and M. So let's go ahead and put that in, right? So character, signature, and we'll make that an array of length 2. So basically what this is doing is I'm saying in my struct, the very first thing I have is 2 bytes, which I will call the signature. Right, so that should basically in your head map across to that part of the diagram. Okay, what else do we got? Next thing is going to be file size. File size is 4 bytes. Well, 4 bytes, that sounds like an integer to me. So we go int of size. That's pretty straightforward. What else do we have? We have reserve 1 and reserve 2. Those, again, right, are 2 bytes, right? I could probably represent them as a character array of 2, which kind of made sense in the past because I knew it was going to be 2 letters. This might be like a number or something. Let me actually try something a little bit different. I'm going to use a short, which is actually going to be a number that I can use basically to represent those 2 bits. I could, of course, use the character representation as well. Here it doesn't matter too much, though, because those reserved spaces don't actually have information that is useful to us. All right, so that looks good. We have 4 more bytes, which is 1 integer for offset, so I'll add 1 more variable here, offset pixel array. Okay, so that's looking pretty good. This all of a sudden is an encode representation of the green part of my diagram over here. Okay, so that looks pretty nifty. Let's see. We won't, quite go through and do all the div header because maybe you'll have to do that at homework at some point. But we can kind of just, put in some temporary stuff for now, right? We'll put in our div header. Looking at how big it is, and actually, we figured out in the previous video too, this is going to be 40 bytes. So what I'll do for my div headers, maybe something like this, char temp of 40. Because the thing is that from the computer's point of view, it doesn't really know what's there, right? You're telling it, is it a number followed by number, is it followed by number, is it followed by character? It doesn't really know. I can actually be super generic for a second and just say, oh, hey, the div header is 40 random bytes, use that. Okay, I could do that, and it would be okay. So that right is maybe, I would put a, not quite done, right, is our note here, right? We would really want to go and break this down like we did for the BMP header and fill in each of these. That way we have access to each of the pieces of information that the div header stores. Okay, so that looks pretty good. I think I'll leave pixel alone for now because pixel, I mean, it's a little bit hard to figure out because it's going to be a variable size, right? That yellow region there. All right, so this is our first kind of way of structuring the information we expect to see in the file. So what's next? Well, we need to actually load our file information into a copy of these two structs. So let's see. My first step is, of course, going to be to actually create these variables, right? So I'm going to need to have a variable that stores the BMP header. I'll just call it header, and also struct to hold that dib header. That'll be my header dib. So that's going to be basically where I read data into. Unfortunately, I made one typo here. Let me just jump back up. Let's put that as a uppercase H, and there we go. Our compiler's happy. All right, so we have basically places to store this information. So what's next? Now we have to actually read it. So this is going to be maybe some new stuff here. Let's read the bitmap header. So the function we're going to introduce here is called fread. fread's job is basically to look at a file stream, right? So this is my file I've opened here, and get a specific number of bytes from it. So there's a few arguments. The first argument is going to be where to basically store the information it's reading. So if I'm reading this sequentially, I look at the file diagram, looks like the signature is going to be the first thing I read from the first header. So we'll put in this. Header.signature. So basically what I'm saying is fread, when you get your data, put it into that signature from the header. Right? The header is here, right? It's in the file, but it's also going to be basically this copy of this struct over here, right? This BMP header struct. So we'll go ahead and add in an ampersand over here. So that looks good. A few more parameters to kind of fill out. The reason why we need the ampersand is, of course, because we need someplace to put the data, right? We're not writing data, we want to be able to put it somewhere. So we need an address to put it. Okay, so header.signature. And then what we'll do is we'll tell our system how much information is going to be, loaded up. So in this case, I have 2 characters there, so I'll go size of character times 2, which will basically give me 2. It's the number of bytes I need in order to read this thing in. All right, so that's good. The next argument there is, it's called n. It's like the number of times you do this read operation. We really just do it once though, so I'll just put in a 1. It's not a big thing. Final thing is basically to put in where we're getting our piece of information from. So there we go. All right, so we're reading in our stuff. This kind of repeats a little bit, right? So actually maybe I'll copy paste a little bit of my line here. I basically want to go through every single piece of my header and read each of them in one by one. There's other ways to do it that might be faster, but we'll do it kind of the individual way just to get started. So we're going to read in size, we're going to read in reserved 1, going to read in reserved 2, and last thing here is offset. Okay, now I have to do a few things here. Let's make this short. And the short, I basically for each of these need to put in like how much to read, right? So if I'm only reading in one integer or one short, well then I should tell it only get that many number of bytes. So we'll do this again over here, and we should be good. All right, so this basically looks at the file and reads those pieces of data one by one and saves them into that struct that we created earlier. So that looks pretty good. Now let me see if I can actually go over and maybe I'm going to copy paste some information over here so that I don't have to type too much. It's coming from magic I prepared earlier. This is just a bunch of printf statements that look at this data we've read in and then displays it. These are printfs, so they're pretty straightforward. We don't really need to discuss them in detail. So this is looking pretty good to me. Let's run it and see what we get. My hope is that basically this information prints and shows us what's inside the file. I'm thinking here, right, the main thing we're going to first expect to see is basically BM, right, for the bitmap header, right? This is the first 2 letters in it. Okay, so not quite what I expected. I see that I didn't get any output. Let's see if this is it. There we go. I had a typo there in the file name, so it just was being quietly failing. All right, so you can see basically this is our information from the file. So notice the BM for the signature, the 70 for the file size, and the 54 for the total amount of header data that the file has. So that looks pretty good. So right now we're basically reading in all the header. So very nice. Now let's say we want to get a pixel data. What will we do? The first thing we're going to need to do is deal with that pesky dib header. Now, in a full program, right, that manipulates images, you would go through and write a complete struct, and you do the same thing we do here. For us, we're going to cheat a little bit and basically just read it as one big block and kind of ignore what's inside. Technically, I should unpack it to find the width and the height, but because I already know it's a 2x2 image, I don't really need to do that right now. So let's just kind of skip through that data, if you would. So let's do an fread again, right? And this time we'll give it the div header. Okay, so that's my other variable I created. We'll go size of char. That's basically kind of a convenient way to say, hey, give me a byte. And then I know that there's basically 40 bytes in that region, so do that 40 times, right? So take out 40 bytes for me. It's a little bit different than the previous ones where I basically put 1 all over the place. This time I'm doing, I'm saying, give me 40 characters, right? Is what this is saying. And that's what I want, so that should be okay. File input. All right, so what this will actually do is basically take those 40 bytes and copy paste them from our file to our struct. We're not going to have to look inside of it. We're just going to move them over. I see that my IDE was complaining a little bit about the definition of close. Yeah, I should probably bring in that other file, but we'll leave it for now. So I have my data kind of is been run through, and now I'm looking at the pixel data. How do I get a pixel? It's this huge array here. What do we do? Well, first of all, right, we know that we're basically standing in front of a pixel, and that pixel will have 3 parts. So it has 3 color components. Now, the standard way people usually say it is RGB, right? Those are the 3 components, right? Like an RGB cable or something like that. So we'll create variables for that. What I'm going to do is I'm going to create a variable of type unsigned char, because that's basically the way I store that one little component, that one little bit of data, right? Every color has 1 byte associated with it. So I'll do R, G, and B. And that'll be kind of my standard colors. So that looks good. Now I need to actually write the code to read this stuff, right? So what will that look like? Well, it's going to be another fread. And there might be another way to do this as well. I'm doing this kind of the long way right now, so you kind of have a reason to talk about everything. We'll use fread again, though, just right now. Fread will basically pull out a byte of information and store it into the B variable. So just as a kind of a FYI here, so we're going to start, read a single pixel is what we're doing here. Format is a little bit different than what we're usually used to. It's BGR, so blue, green, red, right? As opposed to RGB, red, green, blue. So let's see. We'll kind of read in that B first then. So I'm looking at that. Let me get a size of char. I could technically put the number 1 here instead, but I want to be a little bit better and just use the default thing. That way I can basically make the compiler double check that my size is correct. All right, and we'll just read that from the file that we're working with. So I'll put that in there. Okay. Let's see. We're gonna have to duplicate this. Let's see. So I'll copy paste that line. Let's read in green. Then let's read in. Last one will be red. All right. So we got our 3 colors there that are being read in. Let's see if we can print them out. So we'll do a printf on. Let's see. We'll call this like color, and we'll go B equals D. Yeah. And then what do we want to do? G equals D. The D, right, is to display like an integer. Equals D again. Okay. All right, so that's my kind of my formatted text there, and then we'll put our BGR. Okay. So hopefully I have BGR in all the places. BGR, BGR, BGR. All right, that looks good. So with luck, I'll run this, and we'll get basically that first pixel back. Now the first pixel we should get back is actually going to be the red pixel. So hopefully it'll be like 00255. That's what I'm hoping to get. And of course I didn't get it because I have a typo. Let's put this up here. Try this again. Fingers crossed. There we go. 00255. So that's my pixel of red. Recall from previous videos that this thing is stored in the reverse order. Okay, so that's my red. Let's go ahead and maybe repeat this one more time. I am going to do copy paste here just for example. It's not the best way to do things, but we want to just illustrate the point without spending too much time on it. Let's run that. And we should, because this is white, get different components. So looking down here, things are a little bit combined together. BGR 255 is for each of them. So this is going to be our white color. All these are set to on. All right, let's add a slash in there just so my output looks a little bit better when I go to read it. All right, so that looks pretty good. All right, so I have 2 more pixels. Maybe we can go and get those. Let's see what happens. Let's go ahead and go for that 3rd pixel. So this 3rd pixel should be the blue. All right, let's see what we get here. Run this, and we get 00255. So we actually get another red pixel. That doesn't seem right, right? Something's wrong. The issue is that there's this padding, right? So there's actually a 2 pixel pad here. 2 pixel pad in the file. Okay. So actually, right, I can't just immediately start reading. These first 2 bytes are not actually part of the color. They're just dummy data so that the row is a multiple of 4. That's not very useful to me. The file has it, but I don't want that to be part of my color. So what can I do? Well, I can use what's called the fseek command to move past that bit of data. So I'll write the following. Fseek on my input file, right, this is the file that I've been using, and I'll move it forward this amount of bytes. So I'm going to go size of char, well, I could do unsigned char or char. I'll just do unsigned char because that's what I've been using for my pixel format so far, times 2, right? So basically skip that much data. Skip the data for 2 of these pixels, or 2 of these color components of the pixels. So skip 2 bytes. And then what I'm going to do is I'm going to use a special keyword here, seek cur. So that means basically move forward from the place you currently are. There are other options to do things like move forward relative to the beginning of the file. Here what we want to do is work from where we're already at. Okay, so seek cur. All right, so that'll move us forward 2 files. Let's run this again, or 2 bytes. Let's run this again and basically see, do we get back out that proper color? And here we go, blue 0 0, right? So it's pure blue. And if I read one more pixel of data, I should basically get the last thing, which is going to be green. So hopefully it's 0 255 0. And that's what I get, 0 255 0. So there you have it. That's kind of a simple demonstration of loading in a bit of a BMP file and seeing the data that's inside. If we wanted to, we could go a little bit further and basically write out the data, right? So it would be possible for us to do something like write the div back, right? Write the main header back, write the div header back, write the pixels back, and then we'll get a brand new file, right? That's something we could do. Maybe just as a quick demonstration, I'll show you guys how that looks. Short writing example. If I want to write this information back out, basically what happens is I have to open up another file, right? One that I can write to. And basically I'll end up kind of copying, if you would, all of the information that I have currently saved into my structs back into it. So we'll start writing this here. Notice I have it says here WB stands for write binary. Okay. Let's see. Next thing is basically to save that particular data. So let's see. We will go. I'm actually gonna kind of speed things up a little bit here. fwrite, which is what we'll need to update the file, right, to actually save stuff, is very similar to fread. I can actually almost copy the entire thing and then just change this over here. fwrite. No, come on, fwrite. Maybe I'll copy paste that. Just put that in basically everywhere that you had fread, and well, you're good to go. So that's out. Okay, actually, this should be a file out over here. We'll do that. Okay. So we just changed basically where the data was, going to, and then the fact that it's now fwrite instead of fread. The thing that I'm using in my header, the amount of data, all that should stay the same, because I mean, realistically, it's the same as when you brought it in. So we'll do that. And maybe we can even, if we wanted to, right, we could also write out the div header, right, which we didn't really spend a whole lot of time on, but I mean, we do have it, so maybe we'll just throw it there. The pixels are a little bit of work, so we won't do that in this video. Maybe I'll leave it for you guys to do on a homework at some point. Something like this. This is sort of like writing. So this is basically writing a whole struct in one go versus this is writing the different elements of the struct. All right, that's looking pretty good. We'll do an fclose. So that's why I kind of remembered in the background it's fclose, not close. That's what he was getting mad at me. We will close that one, and we'll go up this over here. And now, so if I run this, the output should look the same, but I should basically get a new file on my hard drive that's almost as long, but not quite as long as the original. And basically what it has is the header for the BMP is there, and the div header as well. So it looks like I'm missing one semicolon. Where is it? Oh, it's over there. All right, put in that. Go ahead and run this. Okay, that looks good. Now let's go check. Is that file around? So this is saved over here. Let's see what we have. Sample out code, viewer. All right, you see it's over here. 54 bytes, because it's 14 for the first header and then 40 for the div. We didn't write the pixels, which is another 16 bytes, right? That would get us the full length. So yeah, that's kind of a quick demo there. So now you've seen both reading in detail and then a little bit of writing. And yeah, hopefully you guys have a little bit of sense of how to deal with binary file formats in C, at least when it comes to images. All right, that's all I got for now. I will see you guys in future videos.